So what happens is the signals are taking longer to travel from the SA to the AV. And you can see this because your P wave, the space between the P wave and the QRS, it's either not following. So basically you get P waves without a QRS following it, or you get P waves with QRS following at irregular intervals. Welcome to the Nurse Multiverse podcast. My name is Gene. Today, we're going to be covering the electrical activity of the heart and what happens in one heartbeat. So just want to start with some anatomy and physiology. All right. So we got our heart right there. We got our atrium and we got our ventricles. All right. And what we're going to be focusing is in the structures that provide that electrical activity. Okay. They are two nodes. The sinoatrial node, or SA, and the atrioventricular node, or AV. All right. The sinoatrial node is on the right ventricle, and it has a fiber that goes all the way to the left ventricle, which is called Bachmann's bundle. The same way, we have the atrioventricular node. It travels down the septum, the middle of the heart, and is called the bundle of His, this part. And then it divides. It goes to the right bundle branch and the left bundle branch. All right. So that's pretty much the innervation of the electrical activity of the heart. All right. So we're going to cover it real quick. Sinoatrial node, or SA, it controls atrial activation. All right. With the Bachmann bundle. The atrioventricular node controls the ventricular activation, follows down to the bundle of His, which divides into the left bundle branch and the right bundle branch. All right. Easy terms. Now we're going to be talking about one heartbeat. What happens in one heartbeat? All right. Terms to remember is depolarization, which means contraction, and repolarization, which means relaxation. Another important term is the time measured. All right. We're going to be talking about milliseconds. All right. Milliseconds is 1 second is 1,000 milliseconds. All right. So we look at, this is the way one heartbeat looks. All right. We have the P wave, the QRX complex, the T wave. There's another wave called the U wave, but I'm not going to cover that because I just want to cover something simple. Some point in the future, we're going to be looking at arrhythmias. Today, I'm going to do arrhythmias, but very lightly. All right. Just going to focus on what happens in one heartbeat. Okay. So in one heartbeat, what happens? We're going to talk about the PR interval. All right. The PR interval is the time between atrial depolarization and ventricular depolarization. All right. The atrial depolarized first, and then the ventricles depolarized. The QRS complex, this part right here, shows the beginning of systole and ventricular contraction. Systole is ventricular contraction, and that QRX complex is showing us that. Then we'll go to the ST segment right here, and that's the interval between depolarization and repolarization of the ventricles. When we were talking the other day about STEMI elevation, this waveform is going to be high like that. And that indicates a heart attack. Now, next we go to QT interval. QT interval is the duration of ventricular electrical systole. All right. Which includes ventricular activation and recovery. And last, we got the T wave right here. And that represents ventricular repolarization, which is relaxation. Okay. QT interval, T wave. The numbers are there as you can see them. All right. Each one of these squares represents 0.4 seconds. And each part of this electrical activity is supposed to take place within certain seconds. If those seconds are off, that indicates different electrical problems with the heart. So the PR interval is supposed to be 0.16 milliseconds, or sorry, 0.16 seconds, or 16 milliseconds. The QRS is supposed to be between 0.08 and 0.10 seconds. The ST segment is between 0.08 and 0.12 seconds. The QT interval is between 0.35 and 0.45 seconds. And finally, the T wave is 0.10 to 0.25 seconds. These numbers, when you are taking care of a patient with a problem with electrical activity, and the ones we're going to talk and touch in very lightly is AFib, A flutter, and different conduction problems, which we're going to touch on very briefly because we're going to do a podcast on that. So when you have AFib or A flutter, what happens is there's a conduction problem between the SA and the AV. So what happens is the signals are taking longer to travel from the SA to the AV. And you can see this because your P wave, the space between the P wave and the QRS, it's either not following. So basically you get P waves without a QRS following it, or you get P waves with QRS following at irregular intervals. It's a conduction problem. The other conduction problem that involves the P wave or the PR interval is that PR interval is going to start increasing. So basically it's going to be like that. All right. So it's going to start increasing. So there's different types. You got block 1, block on second degree. There's 2 types of second degree block. And then you have third degree block. We're not going to cover that today. And that's about it, bro. Like, this is pretty much like, it can be a complex subject. So I'm trying to really make it simple. What happens on one heartbeat? And that's pretty much it, guys.